So here's the question. A Zambian human resource expert estimated a multiple linear regression model to predict starting salary of employees in the banking industry based on gender, age, level of education, and previous working experience. The SPSS output is presented below. So, colleagues, basically, this question is similar to the one that we did in question one. Whenever you hear linear regression, okay, it's just an equation of a line where you have a dependent variable and you've got independent variables. So, in this case here, our equations like this to put it into context. You have your salary, which is the dependent variable. Okay, it's dependent on gender, it's also dependent on age, it's also dependent on level of education, and it's also dependent on previous working experience. Okay, this is basically the relationship that we are dealing with here. Okay, someone's starting salary is dependent on their gender, their age, level of education, and previous working experience. Okay, so they've already done the test, and these are the results from the test. Okay, so these are the results done for the test. So, question A, state the measurement scales of the variables gender and level of education. Yes, colleagues, do you remember? Was it in question 16 we had a similar question like this about the measurement scales? What scales did we use last time? And what were we basing them on? Hey, we forgotten. Madam Sylvia, Mr. Vincent. Do you remember the nominal scale and the ordinal scale? Okay, you can find your kicked out. Let me see. Colleagues, are we there? Mm, remember, nominal scale uh, is things that cannot be ranked. Like, no, I'm saying it's similar to question 16, also the same question about asking about the scales. So here, gender cannot be ranked. Okay, nominal scale. Level of education can be ranked. Ordinal scale. Okay. It all depends on the rankings. If they can be ranked or not. Now, someone can argue, so in the Bible, there is a ranking in terms of gender. But now, colleagues, we're in the 21st century, so you don't think there's a ranking of gender anymore, right? So we can see one can be placed higher than the other. Yes. So in the biblical days, gender was part of the ordinal scale. Now, this is the 20th century. Um, Women have fought for equal rights. We have to congratulate our women for fighting for equal rights. So, in this century now, gender is part of the nominal scale. Any questions? Ordinal. Okay. Part B. How many employees took part in the study? Okay, you come here, you look at degree of freedom. Okay. Now remember, the way you usually get the degree of freedom for any study, it's n sample size minus 1. Okay. So here, degrees of freedom 47, 473. So we just have to find n. So we take the negative 1 over the other side. N equals 473 plus 1. 473 plus 1, 474. So 474 employees took part in this study. Any questions? The one which I'm subtracting from is whenever you're getting degree of freedom for any test, this degree of freedom is the sample size minus 1. It's part of the formula. This one is part of the formula for degree of freedom. Yeah. Uh, Can we try and find the value of n? N. Use the p-value rule to comment on the statistical significance of all independent variables. So colleagues, remember, if your p-value is greater than 0.05, then your results can be due to chance or randomness, meaning your results are not reliable basically. Then if your p-value is less than 0.05, then your results are not due to chance and they can be trusted. That is the p-value rule. So our independent variables, gender, age in years, level of education, and previous working experience. These are the p-values here. So for gender of employees, as you see, the p-value is way less than 0.05, meaning the gender, so your salary can be dependent on your gender. Because there's a significant relationship between the gender and the salary level. Isn't that scary, colleagues? Your gender being depends on your salary. Isn't that scary? I think this test was conducted in the Bible times. Because nowadays your gender shouldn't have an impact on your salary. Yeah, but here as you can see, the p-value is low, meaning the gender has an effect on the salary. Okay, because if your p-value is low, it means there's a significant relationship between your dependent and your independent variable. So in this case, we're saying there's a significant relationship between the gender of the employee and the salary. Okay, so this test was conducted during biblical times. Okay, because nowadays your gender is not thing. Okay, so we can say there's a significant relationship between the gender of employees and the salary. Even age in years, as you can see here, 0.035, so less than 0.05. So there is a significant relationship between the age and the salary. Level of education, as you can see, 0.000 less. Okay, less than the the p value. Okay. Now here for previous working experience, 0.352. It's greater than 0.05. So here we can say there's no significant relationship between previous working experience and the starting salary. Any questions? And so that's how you answer part C. You look at the p-value. If it's less than 0.05, there is a significant relationship, meaning this variable needs to be in this model because it has a relationship with the dependent variable. Okay. So gender, age, and level of education, they've got a significant relationship. But previous working experience doesn't have a significant relationship. So it might as well even be removed from the equation. Yes. Queries, questions? Previous working experience. 352. 0 point, that's above 0.05. The relationship is not significant between previous working experience and the salary. Although in real life, your working experience also, it can have a wait. No, I think working experience just helps you with getting the job. They will prefer someone who has got more working experience than the other candidates. But I don't know, colleagues, where you work is working experience. Does it determine your salary? If someone has worked there for 100 years versus someone who has worked for 2 years, but you've got the same qualifications, is there discrepancy in the salaries? Okay. Mhm. Mm, mm. Yeah, I think qualification would be, and your paper. Yeah, so mm, mhm. No, interesting. It's yeah, it's other places. Yeah, you can say, but usually they look at qualifications for who get a higher salary than the other. So there can be special cases like you've explained there. Okay. Yes. Madam Sylvia, you are quiet today. What's wrong? Madam Yvonne, Madam Betha. Hmm. Yeah, 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 yeah. Okay. Understood. Hmm. Sure. In what? Eh. Good luck, colleagues. Okay, I hope you won't hear onions like last time. Hope she doesn't slang that woman. Okay, so interpret the regression coefficient associated with level of education. So you come here. Level of education has a positive coefficient of 650.548. So what this means, if you increase your level of education by 1 year, your salary will increase by 650.548. Okay. If you increase the level of education by 1 year, your salary will increase by 650.48. If you increase your education level by 2 years, then you just multiply 2 times 650.548. So basically, there's a positive relationship between level of education and your salary. So if you increase your level of education by 1 year, salary increases by 650.548. Any no. But if you increase your level of education, your salary will increase by a certain amount, basically. Because I believe if you increase from diploma to degree, your salary will change. Why? Because it's just saying what's this level of education. Yes, that's how we interpret the coefficients like this, okay? If this coefficient is increased by 1 unit, then your your dependent variable will increase by this number of units here. So basically in here, if you increase your level of education by 1 year, salary increases by 650.58. Yeah, that's how you interpret these coefficients. But yeah, in real life, if you increase, uh, let's say, how long does it take to get a master's? 1 year, 2 months? Huh? Oh yeah, oh yeah, yeah. Okay, I'll find out. Yeah, yeah. Yes, that's how you interpret these coefficients, colleagues. Okay, you look at the number there. Okay, so even like here for age, if you increase age by 1 unit, meaning if your age increases by 1 year, according to this model, your salary is supposed to increase by 33 kwacha. Mm-hmm. No, he ain't saying age in years. No, even me, what's this? When I looked at this question, trust me, when I looked at this question, I was like, okay, this question has got some things which need a lot of explanation here. Because even here for gender, if gender is increased by 1 unit, now how can you increase a gender by 1 unit? Yeah, so I'll dig in deep further for these colleagues, but that's how you interpret your coefficients. Okay, whatever number is there, if you increase your independent variable by 1 unit, your independent variable will increase by the number of units on the coefficient. So when we go for residential colleagues, okay, when you meet Professor Buin, we say, sir, question 20, the part for the coefficients. on gender. Does it mean if we increase our gender by 1 unit, our salary is going to go down by 1,525 kwacha? Because as you can see with gender, it's a negative coefficient, meaning if you increase this independent variable, your dependent variable has to drop. The coefficient is telling you, basically, is giving you the direction of how these two are moving. Okay, so colleagues, would you ask that ask that to Professor Abueno? Madam Sylvia, would you ask for me? Madam Betha, would you ask for me? Okay, Mr. Kasono, would you ask for me? Yeah, that's. I know you'll be 200 in class at that time, so I need someone who's not shy. Who's not shy? I'll ask Mr. Twambo. Mr. Twambo, you can ask questions in front of 200 people. The question is, the question is for gender of employees. According to this module, if you increase the gender of employees by 1 unit, means salary is going down by negative 1,525. So he says, sir, can we get a clear picture on that? Even here for even aging years. Yeah, question 19. Yes, madam. Yes, that question, sir, question 19. Mm. And you ask, was it during biblical times? Because we've seen that gender has an impact on salary, which is not, which is not the case nowadays. Okay, maybe some jobs, but no, 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 no. I don't think whatever job you go to, so long as you're male or female, you still get the same salary. So I don't think gender is in real life is real. Unless maybe this was in a Muslim country. Mm, there, gender war. You yes, was it? Did they say the country is being taken place? Zambia. Hmm. So it's not a Muslim country. Which variable has the greatest impact on starting salary? Justify your answer. So for that one, you also come again to the p values. Okay, you see which one has got the lower p value. But here, as we can see, gender of employees and level of education, we don't know which one is small at the moment. So for now, we can say both because then their p values are the lowest compared amongst the others. So you can see the gender of employees and level of education have got the greatest impact on salary because due to their p values. Because their relationships are more significant with the because the p value is telling us the relationship this independent variable has with the dependent variable. So the gender of employee and level of education has got the most significant amongst the other variables. So we can assume that they have the most impact. Any questions? Yes, so for the to see which one has got the most impact. Yes. Now, colleagues, can I get back on you to on this one, part F? I'm still researching it because it's saying calculate, but usually this multiple determination, it's this adjusted R value. This adjusted R. Now, since it's saying calculate, I just want to find out, is there a formula that I need to use? So can I get back to you on this one, question F? With that, Mr. Vincent, is it okay if I get back to you on question F? Mr. Casono, is it okay? Okay. Okay.